These are advanced math notes for Unit 4, Lesson 1. Okay, what you'll need for this lesson is to have your unit circle facts either memorized or using your hand trick or having your unit circle out or your special right triangles, because we're going to be using those quite a bit for this lesson. All right, 4.1, inverse trig functions. Inverse trig functions. Part 1, review from this last unit. You just had these problems on the test you guys just took. It looked like this. Before I write that, I'm going to put up here, find theta such that 0 degrees is less than or equal to theta, which is less than 360 degrees. Okay, so it gave you this restriction, this constraint. Your theta had to be greater than or equal to 0, but less than 360, not equal to 360, less than 360. And we talked about that in class. If 360 was an answer, don't use 360, use 0. It does make a difference. Okay, sine of theta equals 1/2. Okay, so on the test, I'm hoping everyone got 2 answers for this. You're thinking sine of what angle is 1/2? 30 degrees. 1/2 is here. So we're thinking, okay, 1/2 happens at 30 degrees. And then you think, where are my 2 places where sine is positive? Because this is positive 1/2. It's positive in quadrant 1 and positive in quadrant 2. So is 30 degrees one of the answers? Yes, because we are in quadrant 1. And then you have to figure out what's 30 degrees in quadrant 2, and that is 150, and those are your 2 answers. Unless you use radians, and you can use radians, it would be pi over 6 and 5 pi over 6. That's your choice. Another one, what if it was like this? Number 2, sine of theta equals negative 1/2. All right, when you had something like this on the test, hopefully you were thinking the same thing. Sine of what angle is 1/2? 30 degrees. And then which 2 places is sine negative? It's negative in quadrant 3 and quadrant 4. So what is 30 degrees in quadrant 3 and quadrant 4? That is 210 or 330. Sine of 210, sine of 330. Again, if you use radians, sine of 7 pi over 6 or 11 pi over 6. And these 2 would be the answers you would have put in your answer column. I'm just going to show you really quick. Sine of 30, sine of 150 is indeed 1/2. Sine of 210, sine of 330 is indeed negative 1/2. Okay, that is review. How is it going to change for this inverse trig business that we are doing? You've talked about inverse functions before in your previous math classes. How does it work for trig? Inverse trig. Okay, find theta. Number 1, sine of theta equals 1/2. Now hold on just a second. You may be thinking like, wait a minute, we just did that problem. But I am going to give you a constraint. I'm going to tell you that theta is between negative pi over 2 and positive, not equal to. Oh, I'm sorry. Yes, they are both equal to. Positive pi over 2. So theta, negative pi over 2 is less than or equal to theta, and theta is less than or equal to positive pi over 2. All right, so we're going to do the same thing we did before. What angle, what's my reference angle? 30 degrees. Do you see that? That sine of 30 degrees is 1/2. Or use your special right triangle or your finger trick. Sine of this is 30. Sine of 30 is 1/2. All right, with this constraint, where does that put us? Here's negative pi over 2, and here's positive pi over 2. So I can go from negative 90 to positive 90. These are the only two quadrants I can be in. I'm constrained to those two quadrants. Well, only in these two quadrants, where is sine positive 1/2? It has to be quadrant 1. Why is that? Because down here in quadrant 4, sine is negative 1/2. Do you see that? All right, so the only place that sine is positive 1/2, given this constraint, is quadrant 1. And 30 degrees in quadrant 1 is 30 degrees. 30 degrees or pi over 6, your choice. You do not have to give both. All right. Number 2. Let's deal with the sine theta equals negative 1/2, this one that we did here. With the same constraint, negative pi over 2 is less than or equal to theta, which is less than or equal to positive pi over 2. Okay, so we are thinking, reference angle is 30 degrees, because we all know that sine of 30 is 1/2. It's positive 1/2 though, so we have to think this through. Given the constraint, it's still from negative pi over 2 to positive pi over 2, so it's only these two quadrants here, quadrants 1 and 4. These are off limits. In only these two quadrants, and only using these, where is sine negative? Quadrant 4. Yes, I'm aware sine is also negative over here, like we had it here, the bottom two, but I'm given constraints. I can only use the right side, these two quadrants. Okay, so here's the tricky part. What is sine in the fourth quadrant? What is 30 degrees in the fourth quadrant? It's tempting to say 330, but it's negative pi over 2 to positive pi over 2. So when you're dealing with the inverse trig, anything in quadrant 4 is negative. So you're going to go something like positive 30, negative 30. Positive 45, negative 45. Positive 60, negative 60. Positive 90, negative 90. So anything in quadrant 4 is negative. So it's going to be negative 30 degrees. And if you wanted to use a radian, you could, your choice. Okay, negative 30 degrees. And recognizing that negative 30 degrees and 330 are coterminal, they put you at the same place. 330 versus negative 30, it's going to put you at the same place. But we have to use the negative 30 because of the constraint, the way it was written, between negative 90 to positive 90. All right, let's try one more. Number 3, cosine of theta equals negative 1 over root 2. We're thinking, what angle is it? What's our reference angle? 45 degrees. We all know that cosine of 45 is positive 1 over root 2. I am going to give you constraints on this one as well. It's not going to be the same. 0 is less than or equal to theta, which is less than or equal to pi. 0 is less than or equal to theta, which is less than or equal to pi. All right. What does that mean? Let's take a look at our constraint. Here's 0, here is pi. So it can be anywhere between 0 to pi, so it's any of these top two quadrants. This constraint was the right side, the 1 and 4. This constraint is the top, the 1 and 2. Okay, So we know cosine of 45 is 1 over root 2. And we know in these two quadrants, there's only one place where cosine is negative. And that would be in quadrant 2. Why are we in quadrant 2? Because quadrant 1 is where cosine is positive. Now kids might say, well, cosine is also negative in quadrant 3. Yes, it is, but I'm restricted. I can't use quadrant 3. These two quadrants down here are off limits. Okay. So we know we are in quadrant 2. We know the reference angle is 45. What is 45 in quadrant 2? 135. The only place where you use the negatives is quadrant 4. And we're restricted on quadrant 4 for this problem, so it doesn't even matter. 135 degrees, if you want to use radians, you can. 3 pi over 4. Okay, so let's take a look at how it's going to look on your assignment. Okay, let's quickly write inverse sine of x, inverse cosine of x, inverse tan of x. Over here I'm going to write cosecant, inverse cosecant, inverse of secant, and inverse of cotangent. Okay, and we're going to write our constraints. That's these constraints that were given. We're going to write them here for each one. Okay, for sine, it is just as we saw right here. Negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. Okay, I'm using x here instead of theta, but it all works the same. All right, cosine is going to be just like it was here. 0 is less than or equal to x, which is less than or equal to pi. And cosecant works just like the reciprocal of it, so it's going to work like the sine. So it's also going to be between negative pi over 2 and positive pi over 2. And secant's going to work like cosine. It's going to be between 0 and pi. And tangent and cotangent are the only tricky ones that are not the same. Tangents between negative pi over 2 and positive pi over 2, just like it was for sine. And cotangents between 0 and pi, just like it was for secant. All right, so that's what we're going to use to do the inverse type problems. All right, so make sure you have that down. I'm going to flip the page and show you some examples of what you're going to see in class. All right, before we do some examples, I just want to quickly review or just get a quick visual of what is what. Where is inverse sine defined? Inverse sine, I'm going to flip back over. Inverse sine and inverse tan are the same, where cosine and cotangent are the same. Sorry, I'm off screen. Inverse sine and tangent have the same constraint, where cosine and cotangent have the same constraint. Okay, and these just match the reciprocal functions. So, inverse sine and inverse tan are defined between negative pi over 2 to positive pi over 2, so that's the right side. You'll have to remember that it's always defined on the right side, quadrants 1 and 4, where inverse of cosine and inverse of cotangent are defined between 0 and pi, and that is the top half. Which ones do I not have in here are the reciprocal functions, and that's because they match. Cosecant matches with the sine, and secant matches with the cosine. You can add them in there if you'd like. Secant and cosecant. Okay, so whatever it takes to memorize this. I had a young lady tell me one year, and I've shared this with kids every year, they laugh, but they use it. She said she remembered it. She thought of this as suntan. I get a suntan at the beach, and this sideways one is kind of like a B. If you just make a little bump there, I get a suntan at the beach. However you want to memorize it, but you want to remember this is sine and tan, this is cosine and cotangent. In class, I will give you the way that I memorize it, like how I remember which one is which, but I'll share that with you in class. Okay. Evaluate. Number 1, inverse sine of negative root 3 over 2. Okay, so two things you see going on here. Usually it's like sine of 30, sine of 45, sine of 120, but this is not an angle. I usually take sine, cosine, tangent of an angle, and this is not an angle, this is a fraction of the sides. And that is because I'm dealing with the inverse. This is not regular sine, this is inverse sine. Inverse sine or arc sine, they all mean the same thing, means you're working backwards. They're giving you the answer, and they want to know what the angle is. So they're asking you sine of what angle is negative root 3 over 2. Let's write that down just so we know. We don't have to rewrite every one, but this is equivalent to saying sine of what angle equals negative root 3 over 2. So they're giving you the answer. They want to know what was the original angle. Now we have our constraints. Remember, sine is only dealing with quadrants 1 and 4. It's negative, so I know I'm going to be in quadrant 4, and I have to remember that quadrant 4 is negative answers. Negative 30, negative 45, negative 60, stuff like that. Okay, so unit circle it, or your hand trick. Sine of what angle is root 3 over 2? Ignore the negative. It is 60 degrees, root 3 over 2, or your unit circle, 60 degrees, root 3 over 2, or your special right triangle. All right, and it's negative, so it's in the fourth quadrant, so we know that is going to be negative 60. All right, number 2. Arc sine, I said that earlier, arc sine of positive root 3 over 2. Arc sine and inverse sine are exactly the same thing. It's just different ways, different notation, different ways of writing things, saying things, but it's exactly the same. Inverse sine, arc sine, we still have our constraints. Okay, so sine of what angles? Root 3 over 2. We just did that one. It was 60 degrees. Arc sine's constraint to the right side. Keeping in mind, we never use the third quadrant. It's always 1 and 4 or 1 and 2. We never use the third. All right, so where is arc sine positive? Sine is positive. In between these two quadrants, it's only positive here. That's the only place I can be, because down here sine is negative. And in quadrant 1, 60 degrees is 60 degrees. So 60 degrees is the answer, or pi over 3 if you're using a radian. Okay, number 3. Arc cotangent of negative root 3. Okay, so cotangent is here, it's the top, it's negative, so I know I'm going to be in quadrant 2, so it's not going to be like a 30 or 60 or 45, it's going to be whatever 30, 60, or 45 is in this quadrant here. Okay, so let's put our thinking caps on. You can use a unit circle, hand trick, hit pause while you think about it. You're asking yourself, cotangent of what angle is negative, or ignore the negative, is root 3. And let's try this one here. Let's try 30 degrees. Tangent is y over x. Cotangent is x over y, root 3 over 1. Or using your unit circle, it's here. Again, tangent is y over x, so cotangent is x over y, root 3 over 1, that's 30 degrees. Okay, so 30 degrees is our reference angle. Again, cotangent is here, the top two. Where is it negative? Well, it has to be quadrant 2, and 30 degrees in quadrant 2 is 150 degrees. And you can see that right here, 150 degrees, negative root 3 over 1 is what cotangent is, so we are good. This may be confusing. If it is, make sure you're getting your questions down so I can answer them in class tomorrow. Number 4, inverse cos of 1. All right, I'm going to draw this one out. Inverse cos is the top half, and I have 3 quadrantals there. I'm not using this quadrantal down here. 1, 0, negative 1, 0, and 0, 1. I'm looking for the place where cosine is 1. Cosine is the x. Where is it positive 1? It only happens right here at the 0. Remember, we don't use 360, so 0 degrees is my answer. Number 5, inverse sine of negative 1 over root 2. Hopefully this one's a little bit easier. Sine, ignore the negative. Sine of what angle is 1 over root 2? 45 degrees. Where is sine defined? That's the suntan at the beach one. It's on the right hand side. It's negative. Where is sine negative? Only dealing with these two quadrants? Quadrant 4. So is it 45 or negative 45? Negative 45 degrees, or negative pi over 4 if you're using radians. Okay, number 6, arc cosine, which is the same as inverse cosine, of cosine of 7 pi over 2. All right, what the heck is this? This is composition functions, which you have seen. We're doing arc cosine of cosine of 7 pi over 2. Okay, when you're dealing with these, you're going to do this part first, cosine of 7 pi over 2, and then we'll do the outside piece. Okay, cosine of 7 pi over 2. Use your unit circle, use whatever it is you have to do. I'm just going to quickly do it here. I know this is 1 over 2, 2 over 2, 3 over 2, 4 over 2. Because that is the 8, 4 over 2, 5 over 2, 6 over 2, so 7 over 2 is right here. And that is 0, negative 1. Okay, 0, negative 1. So I'm ignoring this piece right here, and I'm asking you, what is cosine of this point right there? And do you see that that is 0? Cosine of 7 pi over 2, it's right there, is 0. So this answer is 0, and I'm going to take arc cosine of the 0. Don't know if you guys can hear that, but that's the running rally coming through, making a whole lot of noise. So if you are part of that running rally, that's you guys right now running out there screaming. All right, I'm going to continue. Arc cosine of 0. What did the 0 come from? Cosine of 7 pi over 2. So now we are working backwards. Arc cosines at the top two. So I'm going to go ahead and redraw those. Oh, I have it right here already. Cosine right, we're up here. Cosine of what angle is 0? 1, 0, -1. This is the only one there, which is 90 degrees. So our final answer is 90 degrees. Okay, number 7. Inverse sine of cosine of 11 pi over 6. Okay, so it's kind of like this one here. I'm going to deal with this piece first. Pause it, try it on your own, and see if we get the same answer. Cosine of 11 pi over 6 is positive root 3 over 2. You can check that on your unit circle. So I'm doing inverse sine of root 3 over 2. Now, inverse sine is the right side, and it's positive, so I know I'm in quadrant 1. So sine of what angle is root 3 over 2? 60 degrees. So 60 degrees is your final answer. Why? Because sine of 60 degrees is positive root 3 over 2. And sine is defined on the top, on the right side, so it's only positive here in quadrant 1. Number 8, sine of inverse cosine of -1/2. All right, so this time, this one I had inverse sine on the outside, this time I have sine on the outside. I still do the inside first. Cosine of what angle is -1/2? Here's cosine here. I know my reference angle, excuse me, is 60 degrees. Cosine of 60 degrees, sorry, cosine of 60 degrees is 1/2. And 60 degrees in quadrant 2, because that's where it is negative, is going to be 120. So I'm going to take sine of 120 degrees. Again, you can check it here. Sine of 120 is root 3 over 2. All right, and sorry, that was cosine. Okay, so I'm going to erase this and start over. Okay, inverse cosine is defined in the top half, so we're going to use our unit circle and figure out where is and it's negative, sorry, it's negative, so it is in that quadrant there. So cosine of what angle is going to give me -1/2, and it is the 120. I want to make sure that I have it written down correct. Yes, -1/2, so it is the 120. And then this piece is review of stuff that you've been doing. What is sine of 120? So you're at that same place. What is sine of 120? Root 3 over 2. All right, inverse cosine of -1/2 is 120. Sine of 120 is root 3 over 2. Last one. This one's going to be on the test. It's also going to be on your homework, but I only point it out because kids always mess it up when they see it. Let me show you why. Sine of arc cosine of -4/5. Okay, kids see this and they just get stuck. I don't know what to do, Mrs. Torres. It's not on the unit circle. I'm stuck. I don't know what to do. Whenever they give you a fraction like this that's not on the unit circle, you're going to draw your picture, just like we did in the last unit. And you do have constraints. It's negative, and arc cosine is only defined in the top 2 quadrants. Remember, we never use quadrant 3. So only in the top 2, where's arc cosine going to, where's cosine going to be if it is negative? Quadrant 2. All right. So I draw my theta, my triangle, in quadrant 2. How do I know that? Because arc cosine is defined in quadrant 1 or 2. It's negative, so it cannot be in quadrant 1. It has to be 2. And cosine's adjacent over hypotenuse. Pythagorean's theorem, or you know this one, it's going to be 3, and it's positive 3 because it's going up. You could do a squared plus negative 4 squared equals 5 squared. When you do all this, you get 3, and we've talked about positive 3 or negative 3. It stays positive because it's going upward. And then they want you to find sine of this picture. So we never found what theta was like we did up here. On these other ones, we found what theta was. I didn't find it here, which is okay, because they're not asking me to find theta anymore. They're asking me to find sine of whatever theta is. Don't know what theta is, but I have my picture. And sine of this picture is 3/5. So 3/5 is the final answer. All right, make sure you have questions ready to get cleared up in class tomorrow. See you then.